In the previous lecture, we talked about some methods for solving first order ordinary differential equation, and we talked about separable first order differential equation, and we also talked about homogeneous first order differential equation. Homogeneous first order differential equation. We now have exact, linear, Bernoulli, these three more methods for solving first order ordinary differential equation. At the end of each method, after taking examples, there are a list of exercises for you. Now we have exact equation. Exact is a method for solving first order ordinary differential equation. We say we first should write down the equation as this. O we let m of xy dx plus n of xy dy equals 0. We must write down the equation in this form. First of all, we must rewrite down the equation. If it's not in this form, we must rewrite down the equation to be on this form. Okay. The coefficients of dx, is called m of xy. That's a function of xy. And the coefficients of dy is called n of xy. Yeah, as you see here, we have this form. We must first write down the equation into this form. And then what we do, we are going to test the equation if it is either exact or not. We are going to test for exactness. How? We are going to take the derivative of m. M is the coefficients of dx. We are going to take the derivative of m with respect to y. If it equals to the derivative of n with respect to x, that means the differential equation is exact. That means that differential equation is exact. It's just for testing of exactness. Okay, we first write down the equation into this form, and then the coefficients of dx is m, and the coefficients of dy is n. We say the derivative of m with respect to y must equal to the derivative of n with respect to x. If it satisfies this equation, it means the differential equation is an exact differential equation. So we just talked about how to recognize an exact differential equation. So here, this is the method of solving the differential equation, which is an exact differential equation. We have m dx plus n dy equals 0. This is test for exactness. If these two are equal, then we follow these steps. If not, we say that's not exact. We try another method. Okay? If it doesn't satisfy this, we say that's not exact. So it couldn't be solved by this method. We should use another method for solving the differential equation. Okay. In the first step, we test for exactness. And in the second step, what we do, we say u of xy, equals the integration of m with respect to x plus phi of y. Phi of y is an arbitrary function. It's constant with respect to the integration, because the integration is with respect to x, and we just added phi of y for the result of the integration. Here we are not going to add c for the integration after taking it. Here you have this constant with respect to the integration. Here بالنسبة that phi of y constant في هناك زي السيبكين زي فاير كراو طاو في هناك زي السيبكين طاو كاريكا فاير بدن راو طاو. Okay, so in the first step, as I said, we just test for exactness. In the second step, we are going to find u of xy. How? We say u of xy equals the integration of m of xy dy dx, sorry, m of xy dx. That means we are going to take the integration with respect to x plus phi of y. That's the second step. In the third one, what we do, we are going to take this. بله وكو سياكا لجي سياكا ليه ما كون صار فانكشنك بالنسبه للطاو كاريكا طاو كاريكا بالنسبه لاكسونيا ام فاي اوف 1 واي كونستانت بالنسبه لطاو كاريكا لا phi is a function. Phi is a function. We say psi of y, okay, lambda of y. Okay, it's the same. It's the same as to say f of y. It's the same.
So you can use f of y.
Yeah, you can write down f, but it's better to write down to follow the same as it's written in the handout. Yeah, it's a function.
And sorry, example اشتغلنا قلنا هاي جرافتينيا ليميت يقول ايش ما شاء الله قال لي اكزاكت
لا exact
ما شاء الله سوري
لا اما مو exactness اما داتا شاوي ام بالنسبه لوريك داتا شاوي ان بالنسبه اكس وريك اكسان اگر اكزامبل كات اكزاكت
شي اكزاكت سوري
equation ka differential equation ka ama differential equation ka niya this is the differential equation. Yes, if it satisfies this formula, it means the differential equation is exact. Look, before we had separable differential equation and also homogeneous differential equation. For homogeneous differential equation, we said if f of lambda x lambda y equals to f of xy, that's homogeneous. Okay, we said f of lambda x lambda y equals to f of xy. This is homogeneous. Okay, that's for testing of a differential equation to be homogeneous or not. But for exact is a method. It's a method for solving differential equation. It's just for recognizing equation to be exact or not. This one, this step. Okay, here, if it satisfies this, we are going to follow the other steps. In the second step, what we do, we are going to find u of xy. We say u of xy equals the integration of m with respect to x plus phi of y. Phi of y is constant regarding to the integration. And in the third step, what we do, we are going to take the derivative of u. We are going to take the derivative of the result for the right hand side with respect to y. We are going to take the derivative of u with respect to y and we equal it to n. That means partial u by partial y equals n. Okay, we know what are n and m. M and n are the coefficients of dx and dy. Okay, and in this step we just equal these two. Then we are going to find phi prime of y. Then we integrate both sides with respect to y. We are going to integrate both sides with respect to y. Then we get phi of y. And then we return phi of y to 3. To this one, to the result of this step. It will be the solution. And then if we have given any conditions, initial or boundary conditions, we are going to use them for finding the constants. Okay, and you have under methods. I'm not gonna talk about the other method to not be confused. Okay, first let's solve an example by this method. Let's solve this example. It says solve this differential equation. If you want to solve this by exact, you must first test for exactness. سرتعب بزن exact يانا. How do you know and a differential equation is exact or not? We must first know what's m and what's n. So m is, what's m? M is the coefficients of x. That's m. And coefficients of dy is n. Okay? So m is 2xy plus 3. And n is x squared minus 1. These are m and n. Testing for exactness, we say partial m by partial y must equal to partial n by partial x. As you see, it's written there. This is this one. That's it. This is the condition to be exact or not. Let's first find partial m by partial y. What's partial m by partial y? This term is 0. ليركاتي كده تشاب بنسبة y ورقين x وابزان كونستانت وابزان جمالي هيك كشن باشا هل وكو كونستانت تعامل لقبل variable كان يترك كاتي داتا شاب بالنسبة لك إلى variable كان ورقين variable كان يترك كونستانت y. Okay, here to take the derivative for this one is 0. How about this one? 2xy. We are going to take this is a constant, it's coefficient. So derivative of y is 1. That means we get 2x. Is it? We get 2x. We get 2x here. So this is partial m by partial y. And partial n by partial x is derivative of n with respect to x. ديرتن هذا داتا شاب بنسبة x ولا داتا شاب x كان ولا جرين أوانك كونستانت سيرك. برام ديرتن هذا x ما هيك إيش ما. So derivative of 1 is 0. Derivative of x squared is 2x. Are these two equal? Yes. These two are equal. That means partial m by partial y, here partial m by partial y equals 2x, and it's also equal to partial n by partial x. These two are equal. That means the differential equation is an exact differential equation. And then we follow the other steps. Yeah. زيادة هالأيام. Look. Yeah. Yes. Look. If you see here, it's always given that differential equation is exact one. Look, here it says what's the value of m to be the differential equation is exact. Yeah. Yes. And here comes the differential equation. Shows that differential equation is not exact. Okay, that's given also always. Not exact. Here in that example, in the last one, it's given the integrating factor. You multiply both sides of the equation by integrating factor, it becomes exact. So you should solve it by exact. Okay. When it says show that the differential equation is exact. After showing that the differential equation is exact, you should solve it by exact. Okay. Here, the first step is testing for exactness. So the differential equation is exact. How about the second step? We said, look, in the second step, we said we are going to find u of xy. U of xy is the integration of m with respect to x plus phi of y. Let's write down it. Here, in the second step, we say u of xy equals the integration of m of xy dx plus phi of y. Okay. Here, u of xy equals the integration of what's m? We found m. M is 2xy plus 3. That's 2xy plus 3. That's m. 2xy plus 3 dx plus 5 of y. Now we are going to take the integration with respect to x. When we take integration with respect to x, we deal with the other variables as constants. أو variable هي constant عاملين قبل. And here we have 2xy. So we just take integration for x. We have x. What's the integration of x? X is x squared over 2. And here we have 2y also. We have u of xy equals 2y x squared over 2. Here we just take integration for x because 2 and y are both constants. Okay. Plus 3 is 3x plus 5 of y. These two are cancelled. That means u of xy equals x squared y plus 3x plus 5 of y. It's the second step. We name this equation star. Okay. Now, in third step, what we do? We said in the third step, we are going to find the derivative of u with respect to y. And then we equal this to n. We equal this to n. We found n. N is x squared plus 1 minus 1. That's n. Okay. And here we have u of xy. We are going to find partial u, this 3. Partial u by partial y, we are going to find the derivative of this function with respect to y. Look, we first find u by taking integration of m with respect to x plus 5 of y. And then we are going to find the derivative of the result with respect to y. And we equal this to n. First, let's find partial u by partial y. What's partial u by partial y? This is u. This is u. This is u of xy. We are going to find partial u by partial y. What's the derivative of this function with respect to y? We say the derivative of this function, the first term is x squared y. It's x squared y. So its derivative is x squared only. We just take derivative for y. Y, its derivative is 1. Okay. ليرة x دوجا نقول قريبا d. أو تعامل د y دا شاوكت شكل دناكت. إكات لير x دوجا y دا شاوكت شكل. بالنسبة y دا شاوري. كات x دوجا هو constant يقوى. So you get only x squared plus 3x. Its derivative with respect to y. What's the result? Yeah. It's 0. That's 0. Because we are going to take derivative with respect to y. As you see, we are going to find its derivative with respect to y. لو ترمي y مانية هذا هم constant. That شاوكي تشيكات. That شاي constant. صفر ناكات. So you get 0. And then derivative of phi of y is phi prime of y. Since we had f of x, derivative of f of x is f prime of x, is it? How about phi of y? It's phi prime of y, because the derivative is with respect to y. This equals n. What's n? Here, n is x squared minus 1. This is n. X squared, we equal this to x squared minus 1. And so these two are cancelled out. X squared from both sides. And we get phi prime of y equals -1. It equals -1. In the next step, we are trying to find what phi of y. Here we have phi prime of y. To get phi of y, to cancel this derivative, we must take integration. Okay. In step 4, we say integration phi prime of y with respect to y equals the integration of -1 dy. This derivative with this integration are cancel out. Okay. Data shout out Arwan. What we get here? Only phi of y equals, in the right hand side we get -y plus c. So this is phi of y. We now return this for equation star. Put in star. We return this to star. What we get? We say that's u of xy equals x squared y plus 3x plus it's minus y plus c minus y. Look, this is phi of y. You replace it by minus y plus c. Okay, and we equal this to 0. Let's say to 0. So x squared y plus 3x minus y equals minus. This is the solution for the given differential equation. ليرة تيست exact تنهابو كبزاين بمبرجي شكالي كنيانا تنهابو كpartial n by partial x and partial n by partial x تنهابو كبزاين بمبرجي شكالي كيانا كباساداني كن انجا بمبرجي شكالي. Okay. So the solution for the differential equation is x squared y plus 3x minus y equals negative c. Let's say c. Sorry? Not at all. See now. That's the solution. That's the solution. Okay? If it's not exact, we should think about another method. Okay? If you could separate them, just look at the example. If you could separate them, it means that's separate. F of lambda x, lambda y equals to f of xy, that means it's homogeneous. You should solve by homogeneous. Okay? And we will have two more methods. Okay? Yes. No, that's only the test. There is only the test for recognizing equation. Okay. Now we have an example. Okay. Now we have an example. It says show that this differential equation xy plus y squared plus y dx plus x plus 2y dy equals 0. It's not exact. That means we should test for exactness and show that partial m by partial y doesn't equal to partial n by partial x. So here m is xy plus y squared plus y, and n is x plus 2y. And from this, partial m by partial y, it equals, yes, partial m by partial y equals, here we are going to take the derivative of m with respect to y, and we get x plus 2y plus 1, and partial n by partial x equals 1. As you see here, partial m by partial y doesn't equal to partial n by partial x. Yeah, partial m by partial y doesn't equal to partial n by partial x. So the differential equation is not exact. And it says show that this differential equation is not exact. That's just for exactness. If partial m by partial y doesn't equal to partial m by partial x, means the differential equation is not exact. And then it says by multiplying both sides with the integrating factor mu of xy, which equals to ex. That means if we multiply both sides of this equation by ex, we get that the differential equation is exact, and then we solve it. Okay, it says solve the differential equation after multiplying both sides by e to the power x. As here, let's talk about exact. So we must solve the differential equation by exact also. After multiplying both sides of the differential equation by ex, the differential equation must become an exact differential equation. Let's first multiply both sides of the differential equation by ex. Here we get multiplying, we say multiplying, let me change the color. By multiplying both sides by mu of xy, which is e to the power x. This is the integrating factor. We are going to multiply both sides by mu of xy, which is e to the power x. Now, what we get if you multiply xy plus y squared plus y, xy plus y squared plus y by e to the power x, dx plus x plus 2y e to the power x dy equals 0. Here, we just multiplied both sides of this differential equation by e to the power x. Now, we are trying to find partial m by partial y and partial n by partial x. And then they must equal. If they are not equal, that means we cannot solve this differential equation by exact. But if they are equal, we can just follow the steps of solving exact differential equation to solve the differential equation. Here, it's easier to find like this. Here, we say partial m by partial y. It equals. This is m. This is m. Okay. Finding partial m by partial y, what we get? Here it's x ex plus 2y ex plus ex. Is it? We get that. Now we are trying to find the derivative of n with respect to y. Partial n, so with respect to x by partial x. It equals. Here we have x times ex. We applied the multiplication rule. If you have two functions which are multiplied, then the derivative is first times derivative of the second plus second times derivative of the first. Okay, so now we get first times derivative of the second. So we get x times ex plus ex. Here we have x times ex. The derivative of this function is first times derivative of the second, which is x times ex, plus second times derivative of the first. Derivative of x is 1, which is ex. We get this. This derivative of x e to the power x. And now we have y times e to the power x. We have 2y times e to the power x. Its derivative with respect to x is 2y e to the power x. Let's check if these two are equal or not. Here we have xex, xex, 2yex, 2yex, ex, ex. So these two partial derivatives are equal. That means the differential equation is exact. Thus, partial m by partial y equals to partial n by partial x. Hence, the differential equation is exact. As you see, and so before the differential equation is not exact. After multiplying both sides by that integrating factor, it becomes exact. And now in step 2, what we do? In step 2, we are going to find u of xy. U of xy. We say u of xy equals the integration of mu of xy. Sorry, m of xy, not mu. It's m of xy dx plus phi of y. Now we're going to find the integration of m. Which m? This one. You're going to find the integration for this one, not the above one, because this differential equation is exact, but the previous one is not exact. So we're going to deal with these m and n. Xy plus y squared plus y. We have the integration xy plus y squared plus y times e to the power x dx plus phi of y. Now we are trying to find this integration. The integration is with respect to x. That means we are going to deal with y as constants. That means we get x y e to the power x plus y squared e to the power x. We just multiply e to x to the bracket. We get y e to the x dx plus phi of y. I just multiply this ax into the bracket. Now we have xy ex. Y is a constant. Let's say y is 4. Okay. Now we have x e to the power x. We can use integration by parts to get the result here, udv. We can use udv to get this result. That means here we have the integration of x ex and multiply the result by y, okay? Because y is a constant, dx. We can use short method. The short method is here, d, this is I. We are gonna checking x بدي دانين بولا بري x بدأ شاي بصفر. Here we have x. Out here man بس بدي دانين كبدأ شاي again بصفر. Here we have ex. Now derivative of x is 1, then 0. We took 2 derivatives for x, so we must take two integrations for e. Integration of ex is to x. Again is x. Now you multiply these two, then minus we multiply these two. We get equals. So the result او كاتا هل كان كاميكيشن يا دوجا بدوجا يو دي في دوجا يو دي في دوجا ليك داني كو دابا شدو كان جامع دابا شدو يكين جامع كاغدال بو اي كيد بم دوجا دواتر انجام دابا شدو. Okay, so here we have the result. Here we have y times x ex plus, sorry, minus ex minus ex. Then for this one, y is constant plus y squared ex. Integration of ex is only x plus y ex plus phi of y. What is this? This is u of xy. That means u of xy equals, and here we have y multiplying by this and that. We get xy e to x minus y ex plus y squared ex plus y ex plus phi of y. Look, y-ex and minus y-ex, these are cancel each other, and we get u of xy, which is xy e to the power x plus y squared ex plus phi of y. This is u of xy. And now we are going to take into derivative for this function with respect to y and equal this to n. Okay, it's the same steps as we did before in the previous example. Here we have partial u by partial y equals n. What's n? We are going to use this n, not the above one, because the above one is not exact. You have x plus 2y times ex. That means let's take first the derivative for this function. The derivative for this function with respect to y, here we get x ex, because which x ex is constant times y, the derivative is only x ex times 1, which is x ex, plus derivative of this function with respect to y is 2y ex plus phi of y equals n. N is x plus 2y all times by ex. That's n. X plus 2y multiplying by ex. If you enter this ex into the bracket, what we get? We get that x ex 2y ex. It's x ex plus 2y ex. As you see here, these are cancelled and these also. These are cancelled. And then we get that this is 5 prime. When you take the derivative, it becomes 5 prime. So 5 prime of y, 5 prime of y equals 0. How about phi? We take integration for both sides. So phi of y equals c. That means we just replace phi of y by c in this equation. Let's say this is star. Put in star. So u of xy equals xy ex plus y squared ex plus c equals 0. And we can say, we move this to the other side, we get xy ex plus y squared ex equals, let's say, c1 or minus c. It's the same. Let's say minus c. This is the solution of the differential equation. If you have given conditions, we use it here to find the value of c. Okay, we use them here to find the value of c. Yes. This is the solution. Now we have some questions of past here. Then we have linear equation. We have linear equation. Sorry, for this one, you can leave it like this here. You even can leave it like this. Let's check, as it's written here in the method. It says that u of xy equals a. Okay, where a is a constant, so that's why we equal this to c. Let's say that's it. This u of xy equals to c. Now we have linear equation. We have linear equation. Recognizing linear equation is so easy. Here we say if the equation is on this form, we say it's linear. If we have dy by dx plus p of x, here we have a function of x multiplied by y. And in the right hand side, you have only x function. We have a function for only x. Okay, this is linear differential equation. But here, this sign is positive. That means if it's negative, that means that belongs to p of x. Again, p of x. Okay, yes. Okay, and here the coefficient of dy by dx must be 1. The coefficient of dy by dx must be 1. Look at the method for solving a differential equation. I mean a linear differential equation. First, we should determine p of x and q of x. What's p of x? P of x is the coefficient of y, and q of x is the right hand side. Okay, the right hand side is q of x, and the left, the coefficient of y is p of x. Now we calculate the integrating factor. We say the integrating factor mu of x equals integration of p of x dx, e to the power integration of p of x dx. Here we say e to the power integration of p of x dx. We are going to find this. this becomes integrating factor. This becomes integrating factor. Okay, after finding that, we say the integrating factor multiplying by y equals the integration of integrating factor multiplying by q. Q, what's q? Q is the terms in the right hand side, dx. And after finding this integration, we are going to move mu of xy, mu of x to the right hand side. As we see, we divide both sides by mu, and we get this. Or you can directly find this one. You can say 1 over mu multiplied by this integration. Let's take an example. It will be easier after taking the example here. We have dy by dx plus 1 plus x of xy equals a to the power x of x. As you see here, we have this differential equation. Its coefficient this way is 1. This is p, and this is q. Okay, that means p of x equals 1 plus x of x. As I said before, p of x is the coefficient of y, and q of x is e to the power x of x. Okay, now finding integrating factor, we say the integrating factor is e to the power integration of p of x dx. This is p of x. We are going to find the integration of this to the power of e. We say mu of x equals e to the power integration of, what's p of x? Let's write down p of x dx. It means it equals e to the power integration of, what's p of x? P of x is 1 over x plus 1, is it? 1 plus x over x. We can give this denominator for each term, for this and that one, and we get 1 over x plus x. Okay? So you get, what's the integration of 1 over x plus x? It's ln x plus x squared over 2, is it? A to the power ln x plus x, sorry, plus x. It's ln x plus x, is it? So now we can say it equals a to the power ln x times e to the power x. We can say that. Now this e with ln are cancelled, and we get only x here. We get x a to the power x. So this is mu of x. This is the integrating factor. These are only simplifying the terms. اما تنها ساده کردن بو که تمام هذا integration که ورقی تا او تری ساده کردن جا کردنویه کل کردنویه لگل ایکو تا هشتر. So now this is mu of x, and we say the solution is, we see y equals, or mu times y equals integration of mu of x times q of x dx. We just find that integration, and that's all. Here mu is x ex times y equals integration of, what's mu is x ex, and what's q? Q is ex over x. This is q. We multiply by ex over x. These two are cancelled out, and we get integration of e to x, because here we have ex times ex. We just add their exponents and become 2x. Okay, this is dx, and it equals the integration of this is 1 over 2 e to x plus c. What's equal to that? This equals to it. That means x exy equals 1 over 2 e to x plus c. And now we must have only y here, so we divide both sides by x ex. We get y equals a half of e to x plus c dividing by x ex. That's all. This is all. This is the solution for that differential equation. It's so easy, and recognizing it is also easy. It's only identifying what's p of x and what's q of x, and how to find the integrating factor, then putting the integrating factor into this row, this one. That's all. Here, it's separated the denominators. It is a half xex. You have e2x plus c over xex. Here, this e2x with this one, I cancel, and you get ex over 2x plus c over that. This is the final answer. And now we have the example. Let's solve this. We can solve this. We have time. We can solve by 5 minutes. Okay. It says by using z to be y squared, by using this, convert the following nonlinear differential equation into differential equation, and then solve it. Sorry? No. Now this differential equation is not linear. It says by using this substitution, it becomes linear. It's the same as the one which we talked about, which was not homogeneous, and you replaced. Yeah, we did the substitution and it became homogeneous. And here you have given condition. Where do we use this condition? We use this at the end. I mean here. We use it here for finding the value of c. But for this example, let's do it. We are going to replace z by, y squared by z. So if z to be y squared, what's dy by dx? We should find dy by dx. So dy by, here we are going to take integration derivative for both sides with respect to x. We get dz by dx equals 2y dy by dx. This is a dependent function. It's dependent function. So we use implicit differentiation. We say it equals 2y dy by dx. That means, and also z equals y squared. That means you replace each y squared by z. And you replace each 2y dy by dx by dz by dx. Or we can say a half of dz by dx equals y dy by dx. Okay? That's it. Now we replace y dy by dx by a half of dz by dx, and also we replace y squared by z. Where? Into this function. Let's check what we get. Here we have x squared y dy by dx. So we said we replace y dy by dx by a half of dz by dx. So let's first write down the given differential equation. We have x squared y dy by dx minus xy squared equals 1. We do these substitutions. We replace y squared by z, and we replace this by a half of dz by dx. So what we get? We get, let me clean this. We get x squared over 2 dz by dx minus xz equals 1. And we said the coefficient of this derivative must be 1. And then that's the condition for linear differential equation. It must be 1. So we divide both sides by x squared and multiplying by 2. So we multiply it by 2 of x squared. Both sides, I mean. So this differential equation becomes dz by dx minus 2 over x z equals 2 over x squared. This is the differential equation. It becomes like this. After simplifying, we get this. Now we're going to find the integrating factor. But before the integrating factor, let's determine p of x and q of x. What's p of x? P of x is the coefficient of y. Oh, here we have z. What's the coefficient of z? Minus 2 over x. We are going to take it with the sign also. Minus 2 over x. And q of x is 2 over x squared. Let's find the integrating factor. We say mu of x is e to the power integration of p of x dx. And this equals e to the power, the integration, what's p of x? It's minus 2 over x dx. This is p of x. What's the integration of minus 2 of x? No, it's minus 2 ln x. Look, we have minus 2 integration of 1 over x. It's the same as this one. Okay? It's minus 2 integration of 1 over x dx. Minus 2 over x, the integration of this integration is minus 2 ln x. It is minus 2 ln x. So it equals e to the power minus 2 ln x. And it equals e to the power ln x to negative 2. It becomes power by using properties of logarithm. And it equals to x to negative 2, which is 1 over x squared. This is the result. This is the integrating factor. This is mu of x. And now we have only one more step to find y. We say y equals integration of, or we can say mu times y. It's better to do it by 2 steps, not to be complicated. We say mu times y. Mu times y equals the integration of mu times q of x dx. Okay. Now, what's mu? Mu is 1 over x squared. Mu is 1 over x squared times y equals the integration of. What is mu here? We have 1 over x squared. What's q? Q is 2 over x squared. 2 over x squared times 2 over x squared dx. We get 1 over x squared y equals 2 over x to the power 4 dx. Now we are going to take this integration and get minus 2/3 x to the power minus 3. We get 1 over x squared y equals minus 2/3 x to 3 plus c. That x to the power 3 is in the denominator also. After taking the integration, I'll bring it down, it becomes positive. Now we are going to find y. So from this, so that's not y, it should be z. I'm really sorry. This should be z, not y. Okay, this is z because we replaced y by z. We said y squared equals z, so it's z. This is z. Only changing y to z, that's all. This is z. And so z equals, you multiply both sides by x squared, and we get minus 2/3 of x plus c x squared. Here we multiply both sides by x squared to get z in the left hand side. Okay, let me write down it again. So z equals minus 2 over 3x plus cx squared. This is z. How about y? We said z equals y squared. So y is the square root of z. As you see here, we have given that z equals y squared. How about y? It's the square root of z. Is it? It's the square root of z. By taking square root for both sides, we get the square root of z. That means here y equals square root of z, which is square root of minus 2 over 3x plus cx squared. That means y is square root of minus 2 over 3x plus cx squared. And then we apply the condition. The condition is y of 1 equals 1. So we replace x by 1 and y by 1 to get the value of c. We get 1 equals square root of minus 2 over 3 plus c. By squaring both sides, we get 1 equals minus 2/3 plus c. And so c is 1 plus 2/3. So c is 5 over 3. This is the value of constant. That means the differential equation y equals, here we just replace c by its value. We get square root of minus 2/3 x, 2 over 3x, plus 5 over 3x squared. This is the differential equation, this is the solution of the differential equation. Look here, we just follow the steps. Yes. كم كونديشن يا اخي؟ ببي او لينير نية، ببي او لينير نية هو ببي ام كونديشنا، ببي ام كونديشنا لينير نية بوتشي لبري واي توانا كي دوا اما عليه تشكاتك ديفرنشال ايكويشن لينير اگر هاتو باوري ديبندنت فاريبل كيك وداتا شاو كانش توانا كان هناك دوايا بلام لير ديبندنت فاريبل واي توانا كي يك نية. So that's why we say it's not linear. We can do this substitution and become linear. After becoming linear, we can follow the steps of solving linear differential equation to get the solution. But here it's for z. We say z equals y squared. So y is the square root of z. After finding z, after finding the solution for z, we can take its square root to get y. And then we use the condition, this condition, to get the value of c. And we found c, which is 2 over 5. So it's 5 over 3. This is the solution. You have any question? So that's enough for today. I'm going to take attendance. Then